Hi, I'm Technomancer, and these tutorials are on alchemy. So, alchemy has a lot of content, so this is going to be spread over several videos. In this video, I'm going to cover a lot of how you work with reagents and how you make stuff in alchemy the manual way. Next video is going to be how you make stuff in alchemy the automated way. The video after that is going to have all the stuff you actually use alchemy for. So like all the stuff you get out of alchemy doesn't happen until video 3. If you're more interested in that, you might want to skip ahead. You can definitely skip the how to automate stuff in alchemy video if you're only trying to make small batches and aren't so concerned about doing things like mass producing iron. So just a heads up, we're not going to cover any of the uses for any of this stuff in this video, just mechanics. So let's get started. So assuming you've already got alchemy unlocked, you should know how to do that from the previous video. There's a few things we're going to need. We're going to need a lot of glass so that we can make glassware. I'm not going to show any of the recipes for things that aren't chemical reactions. Like normal items, use JAI. So we're going to need files, we're going to need flasks, we're going to need glassware stands. These are the main things we're going to need, and we're going to need a bunch of these. And we're going to want the glass versions. There's also crystal versions of all these. If I type in crystal, there's crystal forms, flasks, crystal files, and so on. But we don't have access to the material this needs, alchemical crystal, yet. So for now, we're working with glass. We're also going to need a lot of heat stuff set up. So sources of hot, sources of cold, just set up in our laboratory. Now this is a tutorial, so I'm going to cheat quite heavily. This is a Maxwell's Demon. Don't worry about this too much. This is, if you're interested in this machine, there's going to be a secrets and Easter eggs video at some point, which includes this machine in it, because this machine is sort of a secret feature. So it's basically going to be my infinite free heat and cold source that I'm going to be abusing because I cannot be bothered to set up a million little setups for the purpose of this video. Oop, don't want those to connect. There we go. Alright, so let's cover the really basic stuff. If I have a file in my hand and I want to put it down, I need a glassware stand. I right-click and it goes down. I shift-right-click with an empty hand and I pick it up. Okay? You can also make something called a shell, so like a glass shell, and those can also go in these stands, like this. But right now, we're going to be sticking to our files and our flasks. We're not going to be using this for now. Right, I should be using ceramic cables for this. Sorry. Even with my magic heat source, there are still certain rules that apply. Right, I should be using ceramic cables. So now, let's get started making stuff. So first thing we're going to do is we're going to make a material called quicksilver. We're going to need quite a lot of quicksilver to do alchemy. It's the sort of thing you actually want to make in bulk, but right now we're just going to make a small batch manually. So the item form is frozen quicksilver, but we're really wanting the reagent. So the reagent, so there's a bunch of items that have a reagent form, which is the form we use for crafting in alchemy. So if I look at frozen quicksilver in JI, I can see this little bottle of quicksilver here is the equivalent. So these are one-to-one. Like I can turn the reagent form into the item form, and the item form to the reagent form, one-to-one, no problem. I can also see in JI that the reagent quicksilver has a melting point of -40 degrees C and a boiling point of 560 degrees C. And it doesn't have an effect. We're not going to worry about the effect for right now. That's actually something we're going to talk about later. And we're not too concerned about melting or boiling point either for the purposes of this. Those are going to become important when we try to automate alchemy, the melting and boiling points, but for doing it manually, not so much. And we can click on this little bottle, and JEI will show us all the ways to make Quicksilver and all the things we can use it for. So there's full JEI support built into Alchemy. And you're going to want this. So if we're trying to make Quicksilver, the recipe we're going to use is, if I can just find it, this one. Cinnabar goes to Quicksilver and sulfur dioxide. Now, what's cinnabar? Well, if we click on this, we're going to see, oh, that's just redstone. Okay, I can get redstone dust. That's not a problem. Now, what it very clearly shows here is that this reaction is 1 part cinnabar goes to 1 part Quicksilver and 1 part sulfur dioxide. If we're in this temperature range, and it says it's going to be endothermic. Okay, so what we should expect is if I take some redstone, and we're going to watch everything here with our omnimeter, just to keep an idea of what's going on. If I right-click with the redstone, it's gone into the bottle. It's come out of my inventory, and it's in the bottle now. Okay? If I want to take it out, I can right-click with an empty hand, and it just takes out the item. So if I put a bunch in there, there's 4 in there, and I right-click, and I take out my 4 dust. Okay? Simple so far. So we've got 4 cinnabar in there, and it's basically room temperature, well, air temperature. This is a desert. It's pretty hot. If we want to actually make that into Quicksilver, we need to get it to that temperature we set, right? It said turns into Quicksilver and sulfur dioxide at 360 degrees C and up. All right, how do we do that? Pretty simple, actually. We take our flasks, we put it over here, and now the heat cable's connected, and now it's hot because this heat cable's hot, and it's turned 4 cinnabar into 4 sulfur dioxide and 4 Quicksilver. I want to mention something here. I did this in the flask, this fat bottle here. Let me get rid of this one. This one's the crystal one. I don't want to show that yet. Right? I put it in a Florence flask, which is the fat version. This would not have worked in the file, which is the thin version. The thin version, chemical reactions, which is what that was, do not happen in the thin version. If I were to heat this up, nothing would happen. It would stay as cinnabar. These files are mainly for moving around chemicals, and carrying them around and storing them. They're cheaper, they're smaller. And they can only store capacity 20, which means they can only have 20 redstone dust in it at a time. See, it's full now. To show you how I can move it around, if I put some dust in here, some cinnabar, this bottle has 8 cinnabar in it. If I right-click onto this bottle, it's transferred the 8 cinnabar, so the 8 cinnabar are in the flask, and my file is empty. And I can right-click again to take it back. So files are a great way to move things around, but you cannot use them for chemical reactions. And if I were to put them in the glassware stand, the heat cable won't even connect, because that's really not what files are for. Let's put the rest in here, and immediately that'll do the reaction because it's still hot in there. So we've got this mix of sulfur dioxide and Quicksilver. So let's take our Quicksilver out. I mean, right-clicking's not doing anything. Why not? Well, let's take a look more closely. It is 2,500 degrees C in there. And the contents are, as we can see from the fact that it's bubbling, bubbles mean that there's a gas in there. Little sparkles means it's a solid. And what have I got that's a good example of this? Hold on. Let me just get a quick little thing here just so that I can show what a liquid looks like. Liquids look like little droplets, like that. Okay? Little droplets. Depending on how you've got it set up, it might render those particles in the actual bottom here. It really depends on your settings. I've got it currently set so it renders up here, just because I find it more visible, but you can have it down here. where it makes more sense. I've got it up here for tutorial purposes. But normally it would render like inside the actual glass bulb. So we've got a gas in this bottle. Actually, we've got two. We've got gaseous sulfur dioxide and gaseous quicksilver. The item form is a solid. To take it out, we need this to be a solid. Well, how do we get these to be a solid? Well, now we're going to look at our frozen quicksilver. Melting point, negative 40 C. If we cool it below the melting point, it freezes. This would be when it's a good time to have something set up so you can cool this below negative 40 C. And we're just going to do that. And it's cold now. Very, very cold, as you can see. It's cooling down quickly. You can see it sparkles, which you can tell it's solid. And now I can just take it out as an item. The sulfur dioxide also froze. Actually, this one froze at negative 72, so it was even colder before this became an item form, but we were able to just take it out. So oftentimes when you're working with the items, you need to get things cold so you can take them out. And then to actually do the reactions, you need to heat them up again. Okay? Now, we're not too concerned about the frozen sulfur dioxide right now. We're actually going to throw that away because we're looking at quicksilver. We've just got a bunch of quicksilver. We can use this for stuff. A bunch of these items you get with alchemy can actually be used in a resonance extractor to produce beams, and they're often quite good beam sources, but that's not why we made quicksilver. We made quicksilver because it's an ingredient in other stuff. So the first thing we're actually trying to make, the reason we made quicksilver, is we're trying to get this thing called the, somewhere in here, I think I passed it, the Philosopher's Stone. Lots of the stuff we want needs a Philosopher's Stone to make, and quicksilver is one of the ingredients. Gold? Well, that's pretty easy. That's just a gold nugget. That's not hard. Sulfur and alchemical salt. Hey, how do we get those? Sulfur is actually not too bad. And this is where we introduce the catalyst mechanic. So it says we can get sulfur from either gunpowder or slag. Now, if you look at this recipe, you can see there's a reagent here over the arrow. The one over the arrow is not an ingredient, and it's not a product. It is a catalyst. It needs to be in the bottle for the reaction to happen, otherwise the reaction won't happen, but it doesn't get used up and it doesn't get made. It just has to be there. So if we wash our gunpowder, we can get our sulfur out, basically. And it works at any temperature where, pretty much any temperature, actually. Anything where the water wouldn't be a gas. So let's do that. Let's make our sulfur. So if we just get some water. Now we can actually put this in with a bucket, or we can put it in an ice form. So water in alchemy, this is important, is not normal vanilla water. I know you might think that from the name. This is distilled water. People get confused by this a lot. I can right-click with a distilled water bucket, and I can put it in. This would normally empty the bucket if I were in survival mode, and it's just put in some water. If I right-click with a normal water bucket, nothing happens. Normal water, not chemical-grade water. You don't go in a chemist's lab and have them like scoop up seawater to use in their experiments. They're using distilled water, and so are we. And I could get that out with an empty bucket, except I'm in creative mode, so it's not actually going to fill the bucket. So let's get rid of you and get a fresh one. So we've got our water in there. We also could have used packed ice. Packed ice, which is made with distilled water, is the solid form of water. So we could have done this and then heated up to the sufficiently, because if I just put packed ice in here, it's cold, so it's actually solid form, right? It's negative 100 C, it's really cold, but we could heat that up to liquefy it if we cared. It actually works cold. So we've got this. We're just going to put our gunpowder in. We could use gunpowder or slag, it said. and it said 2 gunpowder to 1 sulfur. So once I put the second one in, we saw the gray sparkles of gunpowder go away, and we saw the yellow sparkles of sulfur. Let's do that again. Blue sparkles from the water, blue liquid droplets from the water, and the gray sparkles from one gunpowder, and the second one, gray sparkles are gone. There's no gunpowder in there. There's the yellow sparkles of sulfur, because sulfur is yellow, and we can pull our sulfur out. And this is just how we make lots and lots of sulfur if we were doing it manually. Obviously, you'd want to automate this, and that's going to be the next video. So hey, that's 3 of our 4 ingredients for the Philosopher's Stone, right? I mean, we're making progress. Well, that leaves the alchemical salt, and oh no, there's a catalyst. So we've got 3 of the 5 ingredients, because we need these catalysts too. Alchemical salt. Again, we're going to introduce a new game mechanic here. There's a bunch of ways to make this stuff. A bunch of different ways you could use, but right now we're going to use this way. This one here. It uses water, mundane salt. Mundane salt is just normal salt. And this little lightning bolt symbol, which we've not seen before, to make chlorine and alchemical salt. What's the lightning bolt? What does that mean? Is that an ingredient? No. It means there needs to be electricity. Well, we can do that. So right now, all of these bottles have been done normally, just with heat. We can add electricity to the mix. And to do that, we need a special block, we need an electrolyzer. Now, an electrolyzer uses forge energy. This is one of the few things in the mod that actually uses forge energy, aka electricity, aka RF, aka FE, aka the million names that electricity is given in modded Minecraft. Basically any of them. And it works. We just place it down. It'll drain FE, whether or not it's actually doing anything. So you might want to disconnect it or shut it off when you're not in use, just to not waste power. And you can see it's sparking there because there's power provided. I've just got a little Leyden jar, which is like a little battery I showed in the previous video. So this is not a renewable infinite source. That will run out eventually. And it, very similarly to a glassware stand, I can just put bottles in it. Like that. So you can just put bottles in it. And as long as they're in there, they count as being an electrified environment. Little lightning bolt, that's what it means. It needs to be in an electrolyzer or something else that lets you have electricity in there. We've got the gold, we've got the sulfur, we've got the quicksilver, and we're about to make the alchemical salt using this machine. So water, normal salt in that temperature range, 20 to 100 degrees C. Well, that's pretty easy. That's like biome temperature. Water and mundane salt. Okay, so we've already got our water in here, and we expect an equal amount of salt. And we're in our temperature range. So if I put it in here, hey, I see little green bubbles. That means we did something right. And I'm going to break this because it's loud. Hey, now all of our water's gone and our salt's gone. We've got alchemical salt and chlorine. Let's just take that out. Salt comes out no problem because it doesn't melt easily. Chlorine is still a gas. We actually have to get it quite cold if we want to get that out. So now I've got our frozen chlorine out. And again, we're not worried about the chlorine right now, so I'm just going to trash it. Okay, all that's left to make our Philosopher's Stone is the Aqua Regia. How do we make that? Okay, well, let's do it. Aqua Regia. Well, the item form I don't recognize, so we must make it with alchemy, and we do. This way of making it requires we already have a Philosopher's Stone. We're trying to make a Philosopher's Stone. We can't use this one. We don't have one yet. So we must use this recipe. And oh boy, what are these? Muriatic Acid, Azotic Acid. This is a long crafting chain. So Azotic Acid, it's just water above 100 degrees C in that electricity box. Okay, Not too bad. Muriatic acid. This one's a little more complicated. There's normal salt and oil of vitriol with water as a catalyst. Where do we get oil of vitriol? Okay, we need water and sulfur dioxide. Oh, thank goodness. Ingredients we recognize. And vanadium oxide. Darn it, there's an ingredient we still don't recognize. This crafting chain is long. What's vanadium oxide? Well, this one's actually really easy, because you can just craft this. Vanadium oxide, you can just make in a detailed crafter with coal. There are zero reactions that actually use it. It's a catalyst in all of them. So it's only a special catalyst that gets used in a few recipes. So don't worry too much. Don't get scared of that. But making Aqua Regia is a pretty long crafting chain, and it's actually the sort of thing you'd normally want to automate. But again, we're just doing it manually. I'd say you'd want to automate it because it's the sort of thing you actually end up wanting quite a bit of. Okay. While I'm here, I should probably finally mention what all these words mean. Isothermic, endothermic, and exothermic. We've been seeing it on pretty much every recipe, but I haven't said a single time what it actually means. These are chemistry words. It means when you do a reaction, the temperature in the bottle changes a little bit. Like when we made our, let's take an example, when we made our Quicksilver, which required us to, one of these, here it is, which required us to heat up redstone, the bottle actually got a little bit colder when the reaction happened. And we know this because it says endothermic. Endothermic means consumes heat or gets colder. Basically that means if we were trying to automate this, we'd need to keep supplying heat to keep it above 360 degrees C, because while it's running, it's going to cool down a little bit. But for manual, we don't really care. We can basically ignore this word. Exothermic means the temperature is going to increase. So for this reaction, which we're not doing currently, it has a temperature range and it says exothermic, the temperature is going to go up. So I know if I were trying to automate this reaction, I'd probably need something to keep it cold below 560 C, because every time the reaction happens, it's going to heat up a little bit. Isothermic, only a few reactions are isothermic. It means they don't change the temperature at all. Don't worry about it. The temperature stays the same. So exo means gets hotter, iso means stays the same, endo means gets colder. I didn't make up these words. They're in the dictionary. You can just Google it if you forget. And honestly, it usually doesn't matter all that much. Okay, so let's assume we skip forward and we've got our Aqua Regia. Are we ready to do the reaction? Pretty much. There's only one thing here that's a little strange. There's this little bomb icon. Should we be concerned? The answer is a little bit. That means this is an exact recipe. All the ratios need to be perfect. If we get it wrong, it's going to break the glassware. That's not too bad. I mean, we can just make a new bottle, but it wastes all the ingredients, and it releases the chemicals, which might not be ideal. So it's not a disaster. It's just like a minor laboratory accident. But for most of these reactions we've been doing, the ratio, we've been following the ratio, but it hasn't really mattered. Like when we made the Alchemical Salt, it said it was going to use equal parts of water and salt, 2 to 2. And when we, oops, that's the wrong item. Darn. So if I were to put them in a little bit wrong, like let's say only put in 8 salt and there's 10 water. This is freezing cold. I need to heat this up. What's the temperature range for this? I need to check. Oh, 100 degrees C. Okay, let me just take that over here then. to our bring it to a normal temperature box. Sure, that should work. And I broke my electrolyzer because it was loud. So we've got 10 water in here and 8 salt. Well, the ratio's wrong, so we had a little bit of water left over. Not a big deal, right? It left a little bit of water over because we had more water than we needed. Not a big deal. And if we wanted, we could get the water out by freezing it. But with an exact recipe, like with the Philosopher's Stone, if one of the ingredients is left over, that's a problem. That will actually break the bottle. So we need to make sure that we just put in the exact same amount of gold, sulfur, and quicksilver and salt before we put it in the zapping machine, the electrolyzer. Okay. Now, here's where I give you a warning, because if I don't warn you, you're not going to notice. And you're going to make the mistake a lot of people make. We're about to get to a higher tier of chemical. We've been dealing with normal chemicals up to now. Quicksilver, gold, sulfur, salt, all normal stuff. Philosopher is a tier 2 chemical. You can't use it. You have to be careful with this stuff. And we know this because if we go to the reagent info JAI, it says must be contained in crystal. Let me skip ahead and show you what that means. This is the item form of the Philosopher's Stone. Assume I already made one. If I try and put it in a glass bottle, bad stuff happens. Watch. Oh no, the bottle broke and the stone fell out, and now it's eating through the world. Okay. Things which have to be contained in crystal need to be in crystal. So remember I said all of these bottles have a crystal version and a glass version. We need the crystal version. The crystal version can do everything the glass version can do, and it can contain the higher tier stuff. It's just flat out better. It does, however, require this alchemical crystal stuff, which you can just make with alchemy. So just quicksilver and alchemical salt, which we already saw how to make. It's not hard. Vanadium oxide, and we just get this stuff. This is the sort of thing you'd want to automate because you use a lot of it. So we should do this, make the Philosopher's Stone reaction in an alchemical crystal bottle. Also, you saw that when it broke, all the chemicals inside were released. Now, some chemicals have effects when they're released, others don't. We saw, for example, that quicksilver, it said effect none, doesn't really care if it gets poured out. Things like chlorine have an effect when they're released, effect toxic, it makes like a poisonous gas cloud. We're going to talk about that more in video 3 of Alchemy, where we show off all the stuff you can do, because those effects can actually be quite useful. But it just means that when the glassware breaks, all the chemicals inside do their effects. So, you know, effect, drop Philosopher's Stone, and the Philosopher's Stone has to be contained in crystal. Sandstone isn't crystal, it's eating through the world. It just sort of falls until you catch it. So, you know, if you're not careful, you might melt a couple of holes in the floor of your alchemy lab if you do something stupid, like try to make Philosopher's Stone in a normal glass bottle. Now we're just going to follow this because I don't know why. And it just ate through the bottom and fell out the bottom. There we go. Hey, that broke bedrock. Isn't that not something you're able to do? Alchemy lets you break bedrock, and we're going to talk about that in a bit. Okay, so we've been talking so much about this Philosopher's Stone crafting, I've got to do it just for closure, shall we say. So gold, sulfur, quicksilver, salt. Let's just make one stone. I'm in creative, I don't really care. Gold, just a nugget, and an Aqua Regia. Oh, Regia salt is the solid form as our catalyst. We've got the right ratio of everything. We've got all the ingredients. we've got the catalyst. We're in the temperature range. No, we're not. It needs to be colder. This is too hot. This says it needs to be negative 15 degrees C tops, so let's cool it down. Nice and easy. It's in the temperature range. All the ratios are right. You should just be able to zap it. If I put my I break this thing every 3 seconds, and then at 4 seconds later, I have to put it down again. Let's see, did I do that right? No, I clearly forgot something. What did I do? I don't think I've ever gotten this right. I always read something wrong. Like every time. What did I put in here? No, it heated up. It was actually hotter than I thought. Didn't cool it down enough. There we go. You know why? It's because this thing itself... Okay. There we go. Those ugly green sparkles are the Philosopher's Stone. Oop, that's water. And the Aqua Regia, which we get back because it's a catalyst. Philosopher's Stone. We need this a lot. Pretty much all the important stuff, we need a Philosopher's Stone as a catalyst, so we need these. Okay. So, what are the things we're going to need? Well, I already showed we used sulfur, quicksilver, and alchemical salt a lot. These are 3 materials you're going to use a lot of, so these are something you want to automate, is automate these 3 ingredients. The next set of 3 ingredients you're going to need a lot of are adamant. Let's get some of that. Aether, which does not have an item form, and can only come in bottled form. And Philosopher, which does not have an item form ever. You cannot freeze these. If I look at like Philosopher in JI, melting always, boiling always. This stuff is always gaseous. Same with Aether. So if this is in a bottle, you cannot take it out into item form. Be careful, if you mix your Aether and Philosopher, you're never separating them again because you cannot freeze them into item form. So these are 3 ingredients we're going to use a lot of, and all of these are made with one of our other ingredients, one of these 3, and the Philosopher's Stone. So if we look at our Philosopher Stone on either gunpowder or slag, which was the way we made sulfur before, but it's the Philosopher's Stone as the catalyst, and we get that other thing plus Philosopher. So, however we were making sulfur before, we swap out the catalyst, and now we're getting that same thing we got before, and we got sulfur and Philosopher. Similarly, Aether. There's a pattern here. Before, we made our quicksilver using cinnabar. Now we're going to do it again, but we're going to add the Philosopher's Stone as a catalyst, and now we still get our quicksilver and sulfur dioxide, but we also get Aether. And adamant is a little bit different. This actually uses bedrock, and we get alchemical salt and adamant. And these are all higher tier materials that, you know, like Philosopher and Aether need to be contained in crystal. So just remember, from this point forward, it's probably just a better idea to use crystal for everything, but if you want to use glass, there's certain chemicals where it's okay. Okay, we need to talk about this adamant, because this is an ingredient we don't know how to get. Bedrock. Where do we get bedrock? Well, the item form is Bedrock Dust. Where do we get Bedrock Dust? How do we get this? To make it, we need to already have adamant. You can't mine bedrock. Well, there's a way. Of course there's a way. And that way, we're going to talk about this a lot more extensively in the video on uses for alchemy. But what we're basically going to skip to is, if we look at Aqua Regia effect, noble acid, the noble acid effect is very important because it lets us get bedrock. If we jump down to bedrock layer, if we have just a little bit of Aqua Regia in a bottle, when you have something in a file like this, you can right-click to pour it out and do the effect in the world. For some things, this is more exciting than for others. Philosopher, for example, has a very, very dramatic and dangerous effect. So if that normally empty the bottle. You can see it's just like eating a hole through the world. You can turn that off in the config. Lots of effects. We're going to talk about this more, like I said, in the uses for alchemy video. But Aqua Regia's effect does a lot of things, but the one we're really interested in is if you right-click on Bedrock with it, it breaks the bedrock and it drops a dust. Now this is a super flat world, so it's really hard to get the bedrock, to catch the bedrock. Normally there's like 4 layers of bedrock so you can actually catch it. But you could also just take this to the nether roof and harvest the nether roof for dust. And you'd use Aqua Regia up. Now, the smart way to do this, and again, we're going to talk about more about what the heck I'm doing here in that other video, is if we mix the salt in water. We've dissolved that Regia salt in the water, and now we can actually throw it sort of like a splash potion and hit a whole bunch of things at once. Or we could boil our Aqua Regia into a gas and sort of have it do a gas cloud that would that would dissolve a bunch of bedrock. So you can use one Regia salt to get a whole bunch of bedrock dust. And we need this bedrock dust to make adamant. But we'd really love to not have to harvest bedrock forever, because that gets quite tedious and we need a lot of adamant. You can make bedrock with adamant and alchemical salt, and you can use bedrock to make adamant and alchemical salt. But it only takes, you get 2 adamant from 5 bedrock, and to make 5 bedrock, you only need 1 adamant. So there's a positive feedback loop here, where if you just keep using up alchemical salt, you'll consume alchemical salt and produce adamant or bedrock, right? So that's the thing to note if you're trying to mass produce this. Okay, we've shown you pretty much all the mechanics, all but one, of how to craft things manually. We've shown you all the important chemicals. We're done, right? Please? No. There is a tier 3. Now, by this point, if you've already got the Philosopher's Stone, you can already start making a lot of the useful and cool stuff in alchemy. Heck, there's a bunch of stuff you can make even before you get the Philosopher's Stone, just not as much. But if you want the tier, so if Philosopher's Stone got you the tier 2 chemicals, the Practitioner's Stone gets you the tier 3. And the Practitioner's Stone, very similar to the Philosopher's Stone, mix gold and those 3 special chemicals that of Philosopher, Aether, and Adamant that I'd said you need a lot of. Mix them all together in the cold. It's an exact thing. Aqua Regia catalyst. And you get the Practitioner's Stone. Practitioner's Stone does a bunch of stuff. They don't really show up in JI. This is, by the way, an example of a destructive reaction. There's a bunch of reactions that are completely useless and are just things you don't want to do. Like if I look at gunpowder, this is just an aside. If you heat it up, you lose the gunpowder and you get nothing and there's a bomb icon. Hey, what do you think that means? What do you think it means happens if you get gunpowder really hot? I wonder. Let's just do that real quick. If you get gunpowder really hot, oop, that was the wrong bottle. Let's try that again. I right-clicked with the wrong bottle and spilled Practitioner's Stone everywhere, made a mess. I've cleaned up now. Don't mind the hole. So if we take the correct bottle this time and just put gunpowder in it really hot, it explodes, which is exactly what you'd expect to have happen if you heated up gunpowder really hot. Just a thing. So, similarly, Philosopher's Stone and Practitioner's Stone don't mix. We've got our Practitioner's Stone. It's very important because that unlocks some of the new stuff, which does not show up in JEI. So what can we make here? And why doesn't it show up in JAI? Well, there's a few reagents which don't have normal recipes. Voltus is one of them. If we look at the recipe, we see Philosopher, Aether, and Adamant, and the Practitioner's Stone Catalyst. Okay. What about Fusus? Hey, that's the exact same recipe again. Adamant, Aether, Philosopher with a Practitioner's Stone Catalyst. How many of these are there? Quite a lot, actually. Stasis Salt. Eldrine. Did I spell that wrong? Yes. There's a whole bunch of reagents that all have, in JI at least, the exact same recipe. Fusus, Eldrine, Stasisol, and Voltus. What the heck? We're going to need our color chart to solve this one. Yep, it's color mixing time. These are the tier 3 chemicals. There's only a few things that use them, so a lot of people just never bother, honestly. But there's some quite powerful stuff you can do with that. Let's take a closer look at our Adamant, our Aether, and our Philosopher. Or more specifically, let's look at the color. Hope you're not colorblind, because if so, I apologize, because this is not going to work for you. Philosopher is red, Aether's green, and Adamant's blue. And those are the 3 basic higher tier reagents that get used in a bunch of stuff. Oh my goodness, they're the 3 primary colors. That's right, it's color mixing time. If you remember our color chart, where we would use beams to mix together energy, potential, and stability to make other colors that do different stuff, it's exactly the same. Voltus is yellow, and the name Voltus, voltage, electricity charge. If we make a yellow mix of Aether, Adamant, and Philosopher, and use a Practitioner's Stone on it, we should get Voltus. So it's going to be looking at the color of the mixture. Well, what about Eldrine? Well, Eldrine, I can tell you right now, and this is all in the book, by the way, is Rift. So if we make a purpley mix, matches the color of the bottle and everything, we're going to get Eldrine. What about Stasisol? Could it be perhaps? Yep, this stuff's pinkish purple, and that matches Equilibrium. Any guesses as to what Fusus is, which has a name that starts with an F and has a teal color? That would be right. That would be Fusion. So let's do that really quickly. We're going to make Voltus, because that's pretty straightforward. I did not mean to delete my Philosopher. And we're just going to take our flask, and if we put in equal parts red and green, equal parts red plus green, we should know from mixing beams would make us yellow. It doesn't look yellow in the bottle because they're separate particles, but let's say that's yellow. Okay, and then what was the other thing we needed for Voltus? Right, we don't need to use any Adamant if we don't want to, because Adamant's blue, and we don't need any blue in the mix. So this, we can just ignore. No Adamant. It's yellow. We're making yellow. Practitioner's Stone Catalyst. Any temperature at all will work. And then we just electrify it. And again, I need my electrolyzer. Did I do that right? Nope, what did I do wrong? You know how no, I did it right. 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 I'm just, why does it, okay, I did it right. I'm just, I don't know, maybe I'm secretly colorblind. Those red sparkles with the Practitioner's Stone, I thought that was the Philosopher for some reason. There's the Voltus, We need to cool it down if we want to get it out. Let's just do that. This is going to take a moment. It's quite hot. Let's make this go faster. We're watching these bubbles. Come on, solidify, solid, go. Oh, there's liquid. Colder. Hey, I can't get it out. Why is that? I've got it to negative 250C. Surely that, nope. Voltus is really cold. If you want to solidify it, it needs to be really cold. And so I'm just going to use an ice box to do the last little bit here. Not an ice box. What am I using? Why am I using that? That's the wrong machine. Okay, I really should just have like a proper setup somewhere to do this, but I'm impatient, and I'm sure you all are too. So I'm just going to continue my ongoing pattern of cheating in the name of education. Now let's just do that. Solidified Voltus. I just used a Technomancy item to help me do alchemy. Shh. Shh, don't tell anyone. We've got our Voltus out. We can do stuff with this. So if we needed Voltus for things, which there are things we need Voltus for, we have it now. And similarly, we can make Eldrine, Stasisol, and Fusus. So that's it. This has been a really long video, I'm aware, but we've covered everything in how you would work with reagents and manually make stuff. We're going to be like referring to this stuff a lot, so if in the automated video I say, well, this is endothermic, so of course we need to put heat in, I talked about that in this video. This is all the basics and all the advanced stuff, like anything involving the Philosopher's Stone or involving the Practitioner's Stone is more advanced stuff we've all covered in this video, so that when I show off, you know, how to mix chlorine, how to take chlorine gas and all that and use it to kill stuff or heal stuff or whatever, we don't have to refer back to, by the way, you remember how to melt things, right? Okay. So hopefully you'll join me for the video where we actually use all of these things we spent this whole video making in the usages video, or you're interested in doing mass production, in which case you're interested in this. And by the way, one last minor thing, even though this isn't really this is kind of an application, is that you now know enough to make things like diamonds, because you now know all of these steps. You know about the Practitioner's Stone. You know how to get Fusus. You know how to make all of these ingredients and stuff. So, hope to see you next time. Goodbye.